Hey guys, welcome back to the channel. In this video we are going to discuss another root locus problem, and in this problem we are going to cover each and every step. The video which I made before this, there was one step left which was not covered, and in this problem it will also get covered. So let's start from the first step. The first step says to calculate the poles, zeros and branches. So the poles of this equation will be 0, minus 4, and if I solve this, we will get minus 2 plus 4j and minus 2 minus 4j. As you can see, there is nothing in the numerator to make the entire thing equal to 0. So there are no zeros in this equation. And if we talk about the branches, it is the maximum of poles and zeros. So we got p is equals to 4 and z is equals to 0. For branches, that is maximum of 4 and 0, that is 4. That means we are going to get 4 branches in the final diagram. Now for step 2, we are going to calculate the angle of asymptotes and the centroid. This is denoted by phi a, and the formula is 2q plus 1 by p minus z into 180 degree. So we know what is p, we know what is z, and we don't know what is q. Q is equals to p minus z terms from 0. So q is equals to 4 terms, that is from 0, 1, 2 and 3. So when we put q equal to 0 and 1 and then again 2, then again 3, we will get 4 values of angle of asymptotes. 45 at q equal to 0, 135 at q equal to 1, 225 at q is equals to 2, and finally 315 at q is equals to 3. Now we will get on to the centroid, and it is denoted by sigma. This is equals to summation of real part of poles minus summation of real part of zeros by pole minus 0. So the real part of the poles are 0, minus 4, minus 2 and minus 2. It will get added. Minus real part of 0, there is no 0, so we will leave it off. And this is 4 minus 0. So we will get minus 4 minus 6 and minus 8 by 4 and minus 2. So centroid lies on minus 2 point, and these are the angle of asymptotes. We will draw the expected waveform. Now we will draw the expected graph. Here the poles lies on 0, minus 4, let's say minus 4 lies here, it is minus 2, and then minus 4 and plus j. Let's say this is plus 2 and this is plus 4j, this is minus 2j and this is minus 4j. Then the next pole is at minus 2 plus 4j here, and the next is here. So we are having 4 poles, and we can see that for the next expected graph, we will take again the poles, and here as we can see that there are only 2 poles which are which we can see when we are standing here. So 2 is even, so the root locus doesn't exist between this pole and infinity. And when we stand between these 2 balls, then there is only one ball which is attached to the wall, then it is even. And if even number of balls appear, then root locus exists between this pole and this pole. So we will highlight it and we will draw expected poles arrows, which I mean the poles, whenever there is a pole, it will generate the arrows away from it, and whenever there is a 0, it will take every arrow inside of it. So here there is a pole at minus 4, there is a pole at 0, and there is a pole at this and this, and we got centroid at minus 2. So the root locus exists between these 2 poles, and the centroid is exactly at minus 2. So we will draw the arrows, and also we will join these 2 and we will draw the arrows. Also we have to join these 2 also. Fine. And to draw the angle of asymptotes, we will just take the mid angle between 90 degrees. Again we will extend it like this. So this is 45, this is 135, this is 225, and from here we'll take it 315 degrees. So this is the expected waveform for first step, and this is the expected waveform for the second step. Now the next step is to calculate the breakaway point. Breakaway point or break-in point can be calculated using this equation and adding k to it. That equation is called as characteristic equation. So we will write that. over here we will get s into s plus 4 into s square plus 4s plus 10 plus k is equals to 0. This is not 10, actually it is 20, and when we multiply the entire equation we will get s power 4 plus 8s cube plus 36s square plus 80s plus k equal to 0. Now we will keep the k onto the one side and we will shift the entire equation into the other side. Then we will get k and we'll take the minus common from every. We will get it like this, 80s. Now we have to differentiate this k with respect to s and we'll equate it to 0. dk by ds is equals to 0. So when we differentiate this by ds we will get, let's do not consider this minus sign, let's take it on this side, and when we differentiate with respect to s we will get 4s cube plus 8 3s are 24s square plus 36 into 2 will get 72s, and this we will get as 80. By solving this equation we will get some roots of s1 is equals to minus 2 and s2 is equals to minus 2 plus 2.4j and s3 is equals to minus 2 minus 2.4j, and here we can see that minus 2, which is a point that is lying between this root locus, so this point is valid. Now let's check for the next number, which is minus 2 plus 2.4j. So minus 2 and plus 2.4j lies between here, so this is also on the root locus, so this is also valid. And if we consider this point, then this point is also valid because minus 2 minus 2.4j is between here, so this is also a valid number. These all points are valid on the root locus. Now the next step is step 4, that is to know the imaginary point which is intersecting the imaginary axis. So we will take the RH criteria on this equation, which is s square s power 4 8s cube plus 36s square plus 80s plus k equal to 0. Now we will take every s in decreasing manner, decreasing power, and we will take the coefficient alternately, 1 then 36 then k, now 8 then 80. And to calculate this number we will multiply these two, subtract by multiplying these two, and divide by 8. That means 8 into 36 minus 1 into 80 by 8. So we will get it as, we'll get it as 26. And to calculate this number we will multiply this and this, that is 8 into k minus 1 and 0, that is 0, divided by 8. So we will get k. This is k. For next value we will multiply this and this, 26 into 80 minus 8 into k by 26. This will come as, so we will get it as 26 into 80, it is 2080 minus 8k by 26. So we will write it as it is, 2080 minus 8k by 26, and after calculating for this we will again get k. So until you get k in the last, you have to do the process in correct manner. Otherwise if you won't get k here, then you have done something wrong in your calculation. So now we will make this as 0, that is 2080 minus 8k by 26 equal to 0. So we will get this as 8k is equals to 2080 and k is equals to 2080 divided by 8. We'll get 260. So k value is 260. Now the equation which is above this will be considered as auxiliary equation. So auxiliary equation is 26s square, and leaving the next one we'll take the alternate, we'll take k. This is the auxiliary equation. Now we will put the k value 260. This will turn into minus 10, and this is equals to, this will come, root of 10 will be 3.16 plus or minus 3.16j. This is the point which is imaginary point on the imaginary axis which is intersecting with the curve. Now for the next step we will go to calculate the angle of departure and angle of arrival. So how to decide that, are we going to calculate the angle of arrival or angle of departure? 5, and here we will calculate So how to decide is it a angle of arrival or angle of departure? See, if you see any imaginary part with the pole, then you have to calculate the angle of departure. And if there is imaginary part with the 0, we will calculate the angle of arrival. So you can take a trick, which is, you know that this is a pole and it will always generate the arrows which will go away from it. So this is getting departure from the pole, and if there is a 0, then it will take every arrow inside of it. That means the arrows are arriving towards the 0. So this is arrival. That is a small trick you can remember. And so we are going to calculate the angle of departure here, because we got the pole with the imaginary values and there is no 0 in our system. So phi d is equals to, there is a formula, 180 minus theta, and here theta is equal to summation of pole of theta and minus summation of pole of theta of zeros. Now this is plus or minus. To calculate theta p and theta z, we have to consider the diagram which we drew previously. This is the diagram, and now we will draw it again. Say, draw like this. There is a pole. Fine. Now we are going to join it like this. See, this is a pole. So this is theta p. This is pole and a pole, theta p. This is a pole and this is a pole. So this is also theta p. So we will name it as theta p1, theta p2 and theta p3. There is no 0, so there will be no theta p. Now we are going to calculate all the angles. So here we can see, if we consider that triangle, this is theta p1. Let's consider it as phi. And this distance is 4 and this distance is 2. So to take tan, we will take 4 by 2. Tan theta is equals to 4 by 2. So phi, tan phi is equals to tan inverse of 4 by 2. So here if we write tan phi, then it will be perpendicular and base 4 by 2, and this phi will, when tan goes to inversing, then it will get tan inverse of 4 by 2, that is tan inverse of 2. And to get theta p1, if we subtract from 180 degree, we'll subtract this angle, then we'll get theta p1. So 180 minus phi, 180 minus tan inverse of 2. So this angle, so we will get it as 116.5 degrees. This is theta p1. And theta p2, we can clearly see that it is 90 degrees. So theta p2 is equals to 90 degrees. And for theta p3, again we will assume this triangle. This is 4 and this is 2. From minus 2 to plus 2, 2. And this is theta p3. If we take tan of theta p3, then we'll get 4 by 2. And theta of p3 is equals to tan inverse of 4 by 2. This is tan inverse of 2. So tan inverse of 2, na? If we remove this, we'll get tan inverse of 2 as 63.43 degrees. So this is P3, 4, 3. Now we will add all these numbers here and we'll get 116.5 plus 90 plus 63.43 minus 0. So theta is equals to, we'll add it with 90 and 116.5. This comes as 269.93. So as we got theta is equals to 269.93, we will substitute into angle of departure, that is plus or minus 180 minus 269.93. And now we will get this as minus 89 approx. And we will get this first point as minus 89 and second as plus 89 degrees. So now we have to draw the final graph on the graph sheet. I have took an empty graph sheet. This is the imaginary axis. Let's take it here. This is the real axis. Now let's take 2 unit as 1. This is minus 2. This is minus 4. Plus 2j and plus 4j. This is minus 2j. This is minus 4j. This is imaginary axis, real axis. Now there is a pole on 0, pole on minus 4, pole on minus 2, plus 4j, pole on minus 2, minus 4j. And now there is a centroid on minus 2 and root locus existing between these two poles. We'll add these two poles also. So now we require breakaway points. So we got breakaway points as minus 2, minus 2.4j. So minus 2 is here and minus 2.4j. 2.4 is somewhere here and minus 2.4j is somewhere here. So these are the breakaway points, and from minus 2 also we have to draw some arrows. And from this breakaway point, the point of intersection that we got was minus 3.16j. This here is 3 and 0.16. We got it here, and minus 3.16j. This is plus 3.16j at k value equal to 260. At k value equal to 260. And the angle of departure that we got was minus 90 and minus 89 and plus 89. So we will draw the curve touching the imaginary axis on this point and also satisfying this angle, that is minus 90. So from this point we will draw the curve like this and like this, and we have to write this is at 89 degrees. And from here this is the breakaway point, that is minus 2 minus 2.4j. So from here we will draw the curve intersecting this point, and from here we will draw free-handedly. Now this is also a breakaway point, so we will draw these arrows that is going out of the point. Finally we got 4 branches, that is from this pole going to this breakaway point, then going to this, again touching the breakaway point, this one path. From here breakaway point 2, and starting from this pole going straight breakaway point 3, starting from this pole going straight breakaway point 4. Hence we got 4 branches in the final root locus. That's it for this video. If you understood everything clearly, then don't forget to click that like button and also subscribe to my channel for more such videos. Thanks for watching.